Welcome back. This is the last session of the series, and we are going to cover three parts. One is going to be a review of CDC and SCD type 2, slowly changing dimension type 2, and the second is going to be migration from DLT to DP, declarative pipeline, and the last one is going to be best practice in production. So we are going to cover these three, and of course, this is part of the series which I was running for the last couple of sessions now. It is on Lakeflow declarative pipeline, and especially Lakeflow Spark declarative pipelines. So that is the series I was running, and this is the end of the series. Today is going to be the end. And most of it is going to be revision, of course, reviewing what we have done. So we have done, of course, the CDC and the slowly changing dimension type 2 before. We have implemented this one in SQL, and also we have reviewed the Python code as well. So just as a review, what we've done is like there is in the declarative pipeline, there is a function called create auto CDC flow. And this one, as you remember, the SQL, what it does is like you create a flow, and then you create also an engine to move the data. So the engine, the flow, you create a flow, and then the engine, you call it, for example, it is the engine is called auto CDC, and this is the engine which is going to move the data. And here they are in one line, in one function. This is called create auto CDC flow, so you don't need to create the way we have done it in SQL. Again, it is declarative, so you say you just you mention your wish, what you want, and the Databricks is going to take over and do all the heavy lifting. Yeah, so that's the key part. So you are going to use dp dot create auto CDC flow. This is what is going. The magic is going to be done by that function, and of course, slowly changing dimension type 2 pattern implementation. We will see that one as well. Multiple views from a single CDC. I think this is the new one which we are going to see, and then history tracking with the start at and end at. Yeah. So this is like today's session, and I'm going to do it very quickly. Of course, the first part is we are going to import pipeline from PySpark, and we are going to declare it as DP, which is declarative pipeline. And then we are going also to import everything from the SQL function as well. So this is the two requirements we need for this one. And the function, this create auto CDC flow function, this one, what it's going to do is like it is going to insert new records, it's going to update modified records with history, and also it's going to delete, soft delete by putting timestamp at the end. Start, like to have two columns, for example, start and end. So it will put it, of course, if it's active, it is going to be null. And if it's not active, then you need to put like a timestamp into the end. So that's what it is going to be done by the create auto CDC flow function. Yeah, and then what's happened is like the table will have also two or three columns, additional columns. One is called underscore start date, another one will be underscore end date. Yeah, so these two columns will be populated by the sequence by. Say, for example, if it is called operations date or update at, whatever the date might be. So the one you are using for sequencing, that will be very useful part. So from there, it is going to populate the date onto that two columns. So everything is going to be done behind the scene. You don't need to worry about it. The Databricks is going to take care of all this stuff. So just you need to say, I want to create auto CDC flow from DP and give what you want. What is the source? Now the source will be like, for example, you are going to create the source using the stream, read stream, and the autoloader as well at the top. and the source is this one, and then we see the keys. The keys here is like a critical one, because what you are saying is here all, for example, if you have 20 or 30 records with the same key, but some of them is update, some of them is deletion, some of them insert. So the system is going to consider them as one unit, as one group, and they will deal with them as one unit. So the where customer ID, this one update it, or this was customer ID insert on this one, and so on. So the keys here is we are providing it as well. We are saying our case is customer ID, and also the sequence, because sometimes data arrive, as we say, as we saw last time, late, and therefore if you don't sequence them, probably you might update the wrong one. So you need to sequence this process. We are providing the update for sequencing, and then the target, where is going to go the data. And this is a table. It's called silver underscore customer SCD version 2. So this is the target. The source is the one we saw before, and the target is the SCD at the end of it. Now the magic is the last one, stored as SCD underscore type is equal to 2. That is a magic. So if you say type is 1, it will not do it for the history. If you say it is you want type 2, then everything the history will be included as well. So that is the magic here, and this is the SCD or slowly changing dimension. So here, this one, as you say, customer ID is the primary key for tracking records. Update at is timestamp to all the changes, and the create SCD type 2 with underscore start at and underscore end at columns. Yeah, so the end at will be null for current version. Previous version have end at set to a date. Yeah, so that's how this is done. And then the new here is like one to many pattern here. Say for example, if you have one CDC source, yeah, we call it global customer, yeah, and then we call we are putting all the source here, CDC underscore customer global, and this one can be used to create a couple of SCD type 2, yeah. So what happens is, like, for example, it's the same, the one we created before. We say the source is the global, this one, and the keys are customer ID, the sequence is update, it's all the same. Now the target we are saying is like we want region A SCD. Yeah? So we want like everyone in region A together in one place, and then we provide this where clause, where region is equal to A, for example. Yeah. Yeah. So and then we say stored as SCD underscore type is equal to 2. So this where clause is just filtering this the origin, the CDC origin, and then it filters by region A, and then it's populating this table. The same thing if you want for the second one. Um, the same thing, customer, all this is the same here. The source is the same. The target, we are changing the name of it. Instead of A will be B, and the where clause is here. Where is equal to region is equal to B. That is the key part. So this is like, for example, if you have a global bank, for example, a global institution, and you have like different customers in different areas, could be in Australia, in Europe, in USA. So what you do is like if you create one pipeline, one CDC source, as you can see here, you create one, and then what you do is like the customers in Australia, for example, they will say uh, where country is equal to Australia, and those in Europe they will say, well, the Europe is equal to Europe, yeah, and those in America might say the where region could be USA. So they filter it based on the column. Of course, the column should be the same in all of them. So there should be. Imagine that we have a region called a region, or we say, for example, a country. If there's a column country, then you can say where a country equal to UK, where country is equal to Germany, where country is equal to USA, whatever it is. So you can filter it using those ones, and then the customers who belong to that country will be their history data with their history. Yeah? The key part here is don't forget we are doing historical data. We are not removing the history. So those customers who were in UK, for example, last time, not active only, even those who've been not using the bank will be there as well if they require to for analysis purpose. So the history is the key. This is SCD type 2, so it will have the history within it. So this is the two files from one source. The benefit is process CDC stream once. The stream will be once. Don't forget it will be cost saving as well, because this one costs money, this streaming. So you do it once and then fan out multiple views. We are creating views, of course, here, as you saw it here, and then each view maintains its own history, significant cost saving, of course. Now, historical data, what you can do is like uh, you can query pattern for CICD type 2 tables. So if you want to query for the history, what is happening to your customer, again, you will have, again, materialized view, the current customer. If you want to know the current customer, for example, what you do is like you do the filter where end at is, if the current is null, yeah? So end date, if it's current, is null. So if you filter it by end date is null, then it will give you the current, all the current customers, yeah? And then if you want like historical customers, those who are not part of you say is not null. Or if you say end date is with end date. Even what you can say is like those customers who were with you, like I don't know, the time limit, for example, last year, for example, yeah. So you can filter it that way, and you can have those customers, yeah. So there, so you have this start at, which is effective from. You have this end date is effective to, and then if it is null, it is active. If it's not null, it's not active. So you can create different kind of reports, historical reports, yeah. Uh, Point in time, you can have here point in time, yeah, where end date is greater than this, or end date. Here, for example, if you have a point of time, this one, if you for example, if you are in you want to know those customers who are here, who are with you before 2024, yeah, then you can put here is less than, yeah, this point in time, and then you will get those data as well. So, and you also if there is a requirement, the keys is not necessarily need to be one. It could be two keys, composite, or three as well if you want to. So you can add as many as you like here, because this is an array. Order ID and line number. Probably there might be a limit, and I don't know. It might be. I'm not sure how many keys are allowed by, but it looks like because array, it looks like there is no n. Could be many, if it makes sense, of course. Yeah. So it does for me. It does make sense if it is more than three. It just creates havoc. There is no gain if you are doing more than three lines. So the keys should be like either one or it could be two. Sometimes might be very useful. The composite one. So so here, what is the benefit? The key concepts are automatic timeline management. Start at when this version becomes effective, end at when this version was superseded. Null is current, and deleted are Boolean flag for soft deletes. And then if it's deleted, what you put is like end date, and then you have change types handling, like for example, insert new records, appears, update existing record, modified, closes old, opens new, yeah. And then also you would have delete is equal to true, end date is set. You'll do different kind of and always best practice, always use timestamp for sequence by. Again, this is very important because this one, it will tell you when it arrived, and then it is easier to order them, yeah. Now use a composite key when needed. You don't need to just use as we were saying before, and then filter where and is null for current state, and what it is used between for point in time queries. Consider data retention policies for history as well. Yeah, because this is very important. Governance side, the retention, there should be a retention policy. They might say we don't want to well, the rules will say, or the government policy or the organization policy might say that customer data should not be longer than you shouldn't we are not allowed to hold customer data longer than 5 years, 10 years, 7 years, whatever that might be, and therefore you need to do something about that. Those who are not within the retention period. So that is the SCD. It is a review, but for Python. Now let us see the migration from DLT to DP work, the new one. Yeah. Now the new one, the Databricks, they call it Spark Declarative Pipeline because they are taking it from Spark. It's an open source, and now what you need to do is like you can convert the imports, update the decorators, move from notebook to .py files, of course, test in development and deploy it in production. So I think if you do it like methodological, if you use method, how to do it, yeah. So just you start with converting the imports. You have all this is one change, and then you update the decorators, of course, and you need to move the notebook to .py files. This is again one of the change. Once you do that one, test it in development and deploy to production. Yeah. So that's the step-by-step migration strategy to follow. Yeah, and let us see what you can see. For example, the syntax one. Yeah. So I don't know if you can see this one. You have this. The old way is import DLT. That's what you are doing. Now you need to say the import side. This is very important. You need to change that one from PySpark import pipeline as DP. So that's you change it to that one. Yeah. So import DLT. It is supported yet, but this is open source PySpark. Yeah. Now the second one is the decorator. Yeah. Streaming table. At before you used to say like at DLT the tables, and then you say streaming is equal to true. You don't need to do that one anymore. Yeah, if it is that one, you just the add dp dot table. That's what you need to say. DLT dot table is again the materialized one. If you are working in batch or materialized, now you need to say add dp materialized underscore view. That's the change. Before all of them was a table. If it is like streaming, you just put streaming is equal to true. And just if you say table, it was like something like materialized. But now you need to change it to materialized view. And now the expect is the same. There is no, there is the same. It said delta at DLT, just changes at DP. And also the DLT expected or drop, just change it to at DP instead of the JJ. It's the same like before. There is no change, the fail and so on, just and instead of DLT, put DP. Yeah, that's the only thing. Now the CDC function here, it used to be DLT. This is major change here. It used to be DLT dot apply change. Yeah, that's the apply change. Now it has been changed to DP. Create auto CDC flow. That is the change here, CDC. Yeah? So that's again, you need to put keep an eye here. So the apply is not it's not anymore. Apply underscore change. And then create auto CDC. Yeah. Now the DLT dot read is now Spark dot read dot table. Yeah, it needs to be spark dot read dot table, and read stream is now read stream. You see, read stream, one word. Just keep an eye here, and dot stable as well. Yeah. So streaming read is this way. So just keep an eye on those ones. So you need to update, you need to change those ones. Yeah. And you will be the rest is the same. There is nothing changed. Also, these are the decorations. But my advice is don't mix things together. Just either do the old one if you are not comfortable with the new one. But if it will be better because you never know, it might not be supported in a couple of years, and therefore it is better for you to migrate, to change. Nobody says it's going to not to be supported, but from experience, that's what happens. Now everyone is going to develop everything in this new one, and they will not be there. I don't think people will put an effort to develop this old one. I'm not sure, but that is how things works, and therefore it is for your advantage to move to the new one, and don't mix things as well, because you might have an error. It might seem working for you here, but you might at one stage it might not do the way it is supposed to do. Yeah. So that is we've been doing this. This is the old way. I haven't given an example from there because we are not. All of it was the new one, and we were been doing all the sessions using the new one, because our session was mainly the Spark declarative pipeline, the new one. Yeah, so we start with that one, and just if you have old script, you can use the one I showed you to do the change here. Yeah, so the import change you to DP, of course, and then the at delta table is called this DP dot materialize view. Name parameters removed, function name becomes table name, everything else stays the same. Yeah, so that's is again I just am not going to go through that one because it is not worth it. It might just confuse people. So for example, the one we're talking about, this streaming, before it was in delta dot table, and then you were saying if it's streaming is true. Now you don't need to do that one. You need to say at dp dot table. Streaming parameters removed. Yeah, implicit is in dp dot table. So name parameter is also removed. Yeah, yeah. So now the materialized view as well, the same thing. They used to be delta, I said before, DLT dot table, and now they are DP materialized view. Yeah, before, if it was streaming, they put streaming in bracket on DLT, and there's no streaming, means like materialized view, and therefore, but now there's nothing like that. So you need to say DP materialized view, and then DLT expect and then DP expect is the same APIs, and the DLT read. Now the read had been slightly changed here, spark.read.table. This is a bit change as well. The CDC, and this one I think is a change. Yeah, the CDC one is here now. The CDC, you were saying now before apply changes, you need to say now create auto CDC flow. So all parameters remain the same, but this is the change here. Yeah, function name more descriptive now. I think I'm not going to do the migration here because I find that like the what is called the free edition is not friendly for if there is new one. It keep breaking somehow. It either looks at table, the file system. It will tell you you don't have access to here. You don't have access to that one, so you cannot change anything. So that's why I'm not doing anything, because I don't want to just to spend time just something which is breaking whenever you do. So it just I want to show you the code here. I'm putting all the codes in GitHub as well. If you want to see it, it is in GitHub. You can download it and see what is going on. Especially this one is very useful. I thought it's very useful because if you have all the codes, you can use this one to migrate. Yeah, yeah. So that's the migration side. Let's spend a bit of time now, probably 1 or 2 minutes in the best practice in production, because the key part is like you develop something, but if in the production is failing, is a problem. All your work is like is gone. So let us spend what is a good practice in production. Number one is we are going to talk is file organization, which is very important. Number two is performance optimization. Number three is error handling. Number four is monitoring and alerting. And number five is CI/CD integration. And the last one is cost optimization. Yeah. So these are the key parts in the production. Yeah. Now for example, this is okay. Now let us see what we get at. For example, this is project structure. When you do your pipeline, again, I think we spent time there before explaining how you can create it there, especially when you were looking at Lakeflow pipeline editor. So you have the asset one, so you can create a folder. You can put like a Git folder, the Git folder which is will be linked to GitHub. So you can create a Git, and then you will have two main in here. For example, you have two main folders. One is to explore your data, and the second one is transformation. The transformation is where your code live. Yeah, the code lives in the transformation. So it is better to have like you can of course you can say ingestion, yeah, and then you can say transformation, and then you can say for the silver, and then aggregation for that one, yeah, within the transformation, of course. So we can say this one, but again, you can also say it in one transformation. You can say bronze, silver, gold, and yeah, you put dot. Of course, now you are not going to use notebook. You are going to use .py. So you organize it. I mean, again, you need to spend a bit of time. You need planning how it should work, because you would have the source code which the pipeline is going to use. You put it in one folder, and then the other side is like support for your work. For example, you have probably you are working in SQL, and then you will have another one in Python, or you will have like some good script. You might have YAML file which you want to use. You have different kind of things. You have also the dependency settings. Yeah, so these like text requirement, the text, you can put them together. So when you need them, you can copy and use them on the setting there. So again, if you have like, for example, you might have like something to do with contract, like we say data contract you were talking about, or the rules we're talking about. So all this stuff which helps your code around your code, you can put them in one place, and you can order them the way it is clear, and it will have a clear separation of concern, easy to test. Team members can work in parallel, also reusable components. Yeah. Now this is one important one. This is like the structure. The second one is you need to also to define schemas. Again, this is we touched it before. So instead of inferring, especially in silver and gold, this one is you need to be like explicit on your schema and data type, and therefore you need to create them once. Yeah, probably might not need that much in bronze, but in silver and gold they are must have, because you need to validate, you need to check it's absolutely correct, and therefore you need to have the schemas. You put them once and reuse them everywhere. Yeah, that's the key part here. So you create once and reuse them in your pipeline everywhere. Yeah. So in here, for example, they have created order schema and the customer schema, and then on the pipeline here, dot schema is customer schema. Yeah. So just simple as that. Yeah. So that's externalized configuration. So this is again another good practice. So, for example, you might have a configuration. You will say where does your catalog, your schema, your checkpoint path, your minimum record per patch. For example, you were saying this is a cost saving as well. So you would have like minimum records per batch. You decide 100, maximum number of percentages. It is 5%. Maximum file per trigger, maximum bytes per trigger as well. Enable static validation, enable auto optimize. All these configuration, you can put them in one place, and you declare them as a class, and then you can reuse them. Yeah, so they are external, and then bring them back when you need them. Yeah, this is again another very interesting, very good. You can call setting.py, and you put it there, and then when you want to use it, as you can see here, yeah, you want to use those ones. For example, where is this Claudia for this maximum file target is going to see it is this is the class dot max file. Yeah, so you just refer it here. Yeah, and pipeline config dot raw data path. So the path you put it here, and then you can bring it here. Yeah, so it is easy. You can come here and change everything, and then this will not affect your code later on. Yeah. Now, again, this is the one we're talking about. You need to create a quality rule library. Yeah, this is very, very good. Again, the best one would be rule. Again, the data contract, which is very useful. That will be the best one for you. The data, yeah, if you create that one. Now, this robust error handling. Yeah, this is again, it is by definition, the error handling is done during this declarative pipeline. Error handling is done automatically by Databricks, but you need to do certain things which will be useful as well. You need to say where to put the files, for example. Uh, say, for example, here the schema location. Where is going to be the schema location? Where are you going to put the corrupt? So rescue columns for parse errors, corrupt records columns for malformed JSON file, for example, metadata columns for debugging. So all this stuff you need to provide them in the code, so that when you do debugging, it will be easier for you when you do your work. Yeah, and then what you do is like you can monitor errors, of course. Yeah, you can see, for example, here you have the filter rescue date is not null, column corrupt is not null. Yeah, so you can filter the date, the table you created, and then you can monitor it that way. Even you can create like a dashboard out of it if you want to. Now, the other one is to optimize for performance. So we have seen a couple of them last time. Yeah, one is like optimize right to true. You will also auto compact is true, for example, which is in your properties. In here, I can see the definition here. Table properties. So you can save them up here, and delta enable liquid clustering true. Yeah, liquid clustering the column also the date customer ID. Yeah, so and then what you do is like when you do like for example, this is the bronze optimize performance best practices, explicit schema, no inference, of course. Yeah, schema controlled batch size, auto optimize enabled liquid cluster or queries. Yeah, so as you can see here, for example, we are doing maximum file per trigger. We are saying bytes per trigger, and so on and so forth. Yeah. Now this is for optimization, and then you need to do unit testing, Lakeflow pipeline. I think I'm going to this one. The unit testing is very important because I don't see a lot of emphasis on it, but I feel that it's very critical when you are a data engineer. You need to do unit testing on your work. Don't forget, our work is now almost like software engineering. So we need to bring the practices which is in software engineering in our side. Now CI/CD is um, first class citizen in data engineering, but this unit testing is still it's not mature yet. So I'm going to have like one session or two on this unit testing in the future. Now, this is like production monitoring as well observability tables. So it is again this is very important one. Yeah, the observability again it is provided there, but what you need to do is like you need to add more information from the system from what you're doing. Say for example, um, if you say event type is flow progress, what you need to do you filter all the event log for that flow progress, and you put it in the table, and then you can count, yeah, how many runs, how many average rows. I mean, you can customize. The key part here is like you have it already, but it is generic. It is for everybody. But for your specific use, before we are talking about this production now, yeah, it's not development anymore. It is production, and therefore you need to keep an eye on certain area where you feel is very critical, monitor it, and then take action when necessary. Now, checklist for your production is like architecture, modular file organization, separate config from code, reusable schema and functions, and clear layout separation like bronze, silver, gold. We've seen the structure. It will give it to you as well. The new editor is very good on that one. It will give you like for example by default it can give you one folder like transformation, or if you take a sample, it can also give you two folders. One is exploration, and second one transformation, and then you can add on top of that one as well. So this is the modular file organization, and then you need to separate the config from the code, and the everything we were talking about, even the data contract separate one, and then the config a separate one, and then you can bring it there. Yeah, you can bring it. You would have a schema. You create your schema there, and then you can reuse it. Yeah, as I said, reusable schema and functions, and then of course the bronze, silver, gold should also be clear. So when you write your code, either you can bronze.py, silver.py, gold.py, and then you write the code for each one of them. Yeah. So that way it just when you separate them, and then also you would know where to go when something gets wrong. So the performance is like it should be explicit schema everywhere. Again, the reason being, don't forget there is a cost in performance. When you do like inference, the system is going to use a compute to do the inferencing. But if you write it yourself, the schema, there is no cost at all. And therefore, it is good to write explicit schema for performance as well as costing. Yeah, the controlling batch size again. This is also cost issues and performance. So you need to, especially if you're dealing with big data and big a lot of tables, this one is also a critical part in performance and costing. So auto optimize it enabled, liquid clustering configured, and query optimization with Z order as well. Yeah. So this is again is very interesting. This order is part of Spark, and therefore, of course, if you've been working in Spark, you have done this Z order many times, hopefully. So this is the performance, and then you need to quality side. You need to do like a comprehensive expectation, error handling with rescue columns, monitoring dashboard for issues, and alerting on quality violation. Yeah, so that is again the quality and the operations. You need to have CI/CD pipeline configured. As we said, like just a simple one would be to do like Git folder. So all your code should be in Git folder, and this way it is easy to push it and to pull from GitHub, and also to have like pull requests and the change there as well. So CI/CD pipeline configured unit. Again, I mean, there is also a very important side to this one. Asset bundles. You need to have these asset bundles in all of your work, of course. And I'm going to have also one session about asset bundles because I feel that's very now is first class citizen, the CI/CD for data engineers. So we need to have them one. So I'm going to run one asset bundle or CI/CD basically. So how to do CI/CD in Databricks, yeah. So the one which probably is we are a bit wiki is the unit testing and integration test, monitoring and alerting, documentation and run books, backup and recovery procedures. Yeah. Now the cost of optimization is serverless compute enabled, appropriate cluster sizing, vacuum all data regularly, monitor compute usage, and review storage costs. Yeah. So so thank you very much for watching and listening. I think this is the end of this session, and if you find something useful in here, don't forget to subscribe and put a comment. If you need any support from for all of the one I said, I'm happy to provide sessions on the one you said you want more support. And also the code is in GitHub. You can download it and use it in a way it fits. So especially if you have like Azure Databricks, yeah, and you have like the non-restrictive way, so that will be the best way to do all this work here. And you can test them there. So that is it. So thank you very much. See you on a different session next.